All right, so this one, it actually did tell you to find the rational roots. So you should have done 0 equals 9x to the 4th minus 40x squared plus 16. So this one might be a little more advanced than what I was trying to get you to, but it's okay to push a little bit. So you should have done, did you find the possible roots?
Yeah, it's 1, 2, 4, 8, 8.
Did you get any more than that?
You divided by 1, 3.
There should be a lot for this one. And then, did you get all these?
Yes.
Did that make sense?
Mm-hmm.
All right. So then, sorry. You're just supposed to kind of start guessing. So like, obviously, I would not go to these guys until the very end. I would try anything except for those. Does that make sense?
Yeah, it makes sense.
And remember, the idea, if I'm going to find roots, the way that we're going to do roots is it's going to be factored. Does that make sense? Do you understand that the roots come from the factors, Forrest?
Yes.
So right here, what do I realize this has?
It's to the 4th power.
Yeah, but what is the square root of this, Forrest?
3.
3x squared, right? What's the square root of this?
4.
And 3x times 4x is 12x doubled. That's not enough, so I can't perfect square this. But I would try it. Do you see what I mean by that? It didn't work, but I tried it. So then I would just guess. So let's try a 1. Now remember, here's one of the parts that you guys possibly are missing. This goes 4, but it's missing a 3, so I got to go 9, 0. So 4, 3, 2, 1, and then the constant. 9, 9, 9, 9, negative 31, negative 31, negative 31. That's not going to work. So 1 doesn't work. So let's try 2. Let's see if 2 works. And it does. 9, 0, negative 40, 0, 16. 9, 9, 9, 18. You with me?
Yeah. 22.
Sure. Huh?
Negative 22. And negative 44.
It doesn't work. Never mind.
Isn't it supposed to be like you bring down the 9 and then 9 times 2 and then the next one would be 18?
Thank you. What in the world am I doing? going too fast. 2, 9, 0, negative 40, 0, 16, 9. 9 times 2 is 18, not a 9 anymore, huh? 18, that's 36. There we go. That turns into a negative 4, which turns into a negative 8, which turns to negative 16, and then it does work. What does that mean I can change this to? That means instead of writing it like that, you can write it as x minus 2 times 9x cubed plus 18x squared minus 4x minus 8. And then it's like you're starting this whole problem kind of over again, Orist, but now you're only using this. Now, it doesn't really help me out except for this part. What does that mean? Instead of having, instead of having a 16 back here, I have an 8, which to me tells me that all of these roots are now not possible for what I have left over. Does that make sense?
Yeah.
So now I can try using those numbers again, and I can do it. I can pretend like I'm using this only, and I'm going to do long division again and try to break it down. Now, I will tell you what I normally do on the test is I give you hints. Like there might be a hint, try 2. And you have to try 2 first, and then that, like, I'll give you the starting one so that it doesn't take you as long to guess through all of those. Does that make sense?
Yeah, because it's kind of like luck.
Yeah. So in order for help us, I try to do that. So I'll help us out again. Negative 2 should work for this one. So we're going to try negative 2 with this stuff. So negative 2. 9. So you see I'm doing the same process that I did over, just kind of doing it over again to try to break this down farther. And when I do that, this is 9. That's negative 18. That's 0. That's 0. That's negative 4. That's positive 8. And there's 0. So then now I can rewrite this right here by using this information. But I got to keep this because that's from my original, right? So I first write x minus 2. Then what would I write next? Because I know it's minus 2 is the root. What does that mean the factor is?
0 plus 2.
Not 0.
Oh, x plus 2, yeah.
And then what's left over is 9x squared minus 4. Well, once I get to that, that right there should be a thing that I remember. What is this right now? How can I factor that further? What should I recognize by now that that is?
You can take the square root of it.
Yeah, what's it called? Somebody help me out. Seriously? Golly, this is frustrating. This is called a...
Is it 3x minus 2?
Yes, but what's that? It's called difference of squares. Both of these have a square root. This is 3x. The square root of this is 2. And there's a subtraction. It's called difference of squares. And the way it factors is 3x plus 2 and 3x minus 2. And now I have that thing completely factored out.
Do you have to list the zeros?
Yep. So what makes this bubble 0?
2.
What makes this one 0?
Negative 2.
What makes this one 0? Maybe not be so straightforward. So you might have to go 3x plus 2 equals 0. And then you minus 2, 3x
3 over
equals, 2. Yep. But it'd be a negative.
Oh no, 2 over 3, yeah.
Negative 2 over 3. And then this one is just going to be a positive 2 over 3. So there my zeros.
That makes sense.
But this is the old crap that we have to remember, the difference of squares. Once I get it to quadratic, I try to factor it using all the ways that I taught you at the beginning of the year. So you kind of just keep going. You keep using synthetic division, until it gets to something that I can manage, which is something that's just x squared, and then I factor it the old school way. Does that kind of make sense? That's a good question. All right, try this one. I'm going to try to start us off with some easier ones. So try number 9. And it tells you to find all the rational roots. So you're doing exactly what I just did, but this one shouldn't take as long because it's the possibles are much smaller, right? It's just a 1 and a 3 that you're going to be using the factors of. So it should be much simpler. Go ahead and do that. I'll give you a couple minutes to try that on your own.
Do we do both of them?
You are to do only number 9. If you finish number 9, you can go ahead and start working on number 11 because we're going to do number 11 right after that.
Okay.
All right, so let's try these examples. So the first thing it tells me to do is it says just to find the possibles. So we're just going to come up with a list. Instead of having an infinite amount of possibilities, we're going to make this list a lot shorter. So it's f of x equals, hopefully I don't write this down wrong, x cubed plus x squared minus 5x, like plus 3. All right, so I would go, okay, my possibles, well, this one should be fairly easy because my constant, or my p, which is my constant, is 3. It's right here. And the factors of that are 1 and 3. That's it. And then my q, which is my leading coefficient, is 1. So the factors of that are 1. So the possibles are just plus or minus 1 over 1 is 1, and then 3 over 1 is just 3. So my possible list is really short. It's very nice. So that's the answer to the first part of the question. That literally might be a test question. Just ask you, give me the list of all possibles. If it is just the possibles, I'll guarantee you that it's going to be more than 4 long. Probably. I would say that it's one of the ones that it could have a bunch of them, just to make sure you know how you're supposed to do this. But that will be just a test question, probably just to find the possibles. Next, it then says to find the reals. So what I have to do is I've got to take this right here and I've got to break that sucker down. And so I go, okay, let's see, how could I break this down? Well, one of the ways we actually did this, and I just want to bring this up, is we actually said when we have 4 terms, you can try to solve by grouping. We talked about how we could do this. Make sure you put a plus sign here. But when I do this, I pull out an x squared. This is from old, and this turns into x plus 1. And when I go to here, there's nothing that it has in common, so I'm left with just a 5x plus 3, a negative 5x plus 3. And these don't have the same thing in the bubble, so it doesn't work. So sometimes we said we try to factor it, and it doesn't work. You guys need to be okay with that. Failure's okay sometimes, and it's like, I tried it one way, it didn't work, okay, back to the drawing board. So when it doesn't work, we can do this thing called synthetic division, and we literally just guess one of these. So we try 1, okay, 1, negative 5, 3. This one's nice because it goes all the way from 3 to 1 down to nothing. Drop down 1, 1, 2, 2, negative 3, 0, ding, ding, ding. This is a root, which means x minus 1. This would make that bubble 0, is one factor, and then this stuff is the leftover stuff, which is x squared. It's the first coefficient, plus 2x minus 3. And then once we get to quadratic, we go, hey, I can break this down using the old school way. So I still write the x minus 1, but then here I say, hey, this says different signs. So I subtract. This says I need 2 numbers that multiply to 3, but subtract 2, and the bigger number is positive, so I have different signs. So one's plus, one's minus. 2 numbers that multiply to 3, but subtract to 2 is 3 and a 1, and the bigger number goes to the positive, so x plus 3, x minus 1. And that means my zeros, what makes this bubble 0 is 1, what makes this bubble is a negative 3, what makes this one is a 1, which is already listed, so I don't have to list it again. So these are my zeros, aka my x-intercepts, also known as your roots. Now, this question did not ask me to do this. I am furthering this. Let's say they asked me to graph this question. Let's say the book said, hey, instead of just finding those zeros and finding the possibles, what if I asked you to graph this? Well, we would actually have to use, yeah.
Why do you? Oh, I understand why you only listed 1, 1. Okay.
Yeah, because they're both the same root.
Yeah.
Yep. So when we ask them to graph this, we're actually going to use both of these. We're going to use this form, which is called factored form, and this right here, which is called standard form. Actually, both those things, this and that, are the same equation. They're just in different forms. It's like this one dressed up, you know, like sporty, and this one's dressed up for like the prom or something. It's the same person, They just dress differently, right? So those two things are the same, but we're going to use both of them to help us get the picture of the graph, because this right here is good for x-intercept. It's awesome for x-intercepts. This right here is good for my in behavior, and it's also good for my y-intercept. So I can get some key points from both of them and put them together to make a nice, pretty graph. So here we go. First thing is 1 was an intercept, 1, 2, 3 was an intercept. Right here, I know that this thing is odd and it's positive, so I know it's down up is my in behavior, and I know my y-intercept is positive 3. So I go 1, I don't know why it does that. 1, 2, 3. And when I try to do this, I might do something like this, and then I hopefully tell me why this is wrong. Someone help me out. There's a couple reasons why.
It doesn't go up at the end.
Right, it's supposed to go up at the end. And I know that it's supposed to be down up. I also know because it's x to the third power, it has to have 2 or no turns. This only has 1 turn. So I know because of this reason too that this graph is wrong. So this is no bueno. It's not good. So let's go back up here. And this is something we talked about before. Right here, how can I actually rewrite this? It says x minus 1, x plus 3, and then another x minus 1. How can I rewrite that actually?
X minus 1 squared.
Why is that important to think about? What does this mean when it's something to the second power? Remember, if it's say it again.
That it reoccurs.
So but there's a word I'm looking for. So there's supposed to be 3 roots. If it's x to the third power, this thing is supposed to have 3 roots. Well, right here, I only have 2. Why? What does this 1 count as?
A multiplicity? Maybe?
Yes, that's the word I was looking for. This has a multiplicity of 2, and I told you something before the break. When something has an even multiplicity, it actually hits the x-axis and bounces and goes back up. Anything that is even multiplicity hits and goes back up. Anything that is odd goes through. We did that in 3-5. So this would be the graph of this, and I knew that this bounced because of this multiplicity right here. And then it matches my in behavior like it should. So there's the graph. Did that make sense? Hello? Any questions?
It makes
That
sense.
makes sense.
Do you guys remember the multiplicity thing that we talked about before the break?
No, I'm glad you went over it though, again.
It was that one that we said, hey, I want you to draw a graph like this. And I gave you it in factored form. And all you had to do was go, okay, this is a 0 is 1, the 0 is -3, the 0 is 2, and then at -3 it was odd. And so the other thing was we said this is 2, 3, 4, 5, 6. So it's x is 6 power, and there's nothing that's going to make it negative. So it's going to start up and end up. We kind of did this. And so I know this one starts from here. Since it's odd, it goes through there. Since it's even right here, it hits and bounces back down. And then since it's odd on this one, it hits and goes through. We kind of did that on 3-5. And we talked about how when it's even, it hits and bounces, and when it's odd, it goes through. When it's odd, it goes through. That was that multiplicity thing. All right, number 11. Do you guys need a little bit more time now that we went over that? Would you like some more time to look at 11 a little more? Okay, good, good. I'm glad you guys would like some more time. Go ahead, please try number 11 and see what you can do with it. Try to graph it if you can. So try to find the possibles, then try to find the roots, and then if you can, try to graph it. a sketch of it. All right, I'm going to call on some of you guys to help me out with this one, so you better make sure you have this. If not, you need to ask a question. All right, Tucker, what am I supposed to do first?
I don't know.
Tucker.
Yes.
You can stay unmuted, please.
All right.
Do you understand how to find the possible roots?
Not really.
Okay. Do you understand what the constant is?
Isn't it 2?
Yes, it is. Can you tell me what the factors of 2 are? Numbers that go
1 and
into
1.
2? What?
1 and 1.
No.
What?
1 is a factor. What other number goes into 2?
I don't know. 2.
Yes, it does. There you go. Those are the factors of 2. Do you know what the leading coefficient is?
X.
The number in front of the highest power. If there is no number, Tucker, what is it understood to be then?
1.
Thank you. What are the factors of 1?
1.
Then to find the possible roots, Tucker, you take all these factors right here and divide them by all these numbers right here. Well, since there's only 1, all you have to do is take 1 and divide it by 1, plus or minus 1. Tucker, where do you do your schooling at?
Say that again.
Where are you in your house that you're doing your schooling? Because you might want to find a quieter place, because it's probably hard to focus on me and hear what I'm saying. And you got all that in the background, bud.
All right.
So, I mean, Algebra 2 is tough. It's not something you can kind of pay half attention to. So if it's me, I want to find a quiet place so that you can focus on what's going on. So you're supposed to take 1 and divide it by 1, which 1 over 1 is 1. Then you take 2 divided by 1, which is 2. So all my possible roots are just positive and negative 1, positive and negative 2. Thank you for your help, bud. That's all you have to do to find that, though.
All right.
All right. Ashton,
Yeah.
what do I do next?
You try and find the roots.
Okay, how do I do that?
You start with 1 and you put it in the box, and then you do, I forget what it's called. It's something division.
Yeah, synthetic.
Yeah.
By the way, you don't have to start with 1. Just so you know, we just do it normally with 1 because it's the easiest number, I think. But really, if you look at it as you start to do this more and you think, you know what, I don't think 1's going to work out because the numbers, maybe this number in here or one of these numbers is crazy high or something. You're like, 1's just not going to get it done for me. You're just choosing whichever one.
Yeah.
So we can try 1. Like I said, but I just wanted to make sure you guys understand we don't have to do 1 every time. Just do it because it's an easy number to work with. 1, 1, 5, 5. Right? Am I doing this right this time? 10,
10.
10, 12. In fact, 1 doesn't work. So let's try -1. The reason I would try negative is, what do you notice about all these numbers right here?
They're all positive.
And if I just keep adding positive numbers to them, what are they never going to do?
Equals 0.
So do you see how when I saw they're all positive, I'm going to go, hey, you know what? Let's try a negative number because maybe I need to, I need some positive and some negatives in order to cancel out to 0, right? So I'm going to make that negative appear by forcing this number up here to be negative. Or like I said, none of these numbers ever become negative. You with me on that logic?
Yeah.
1, -1, 3, -3, 2, -2, 0. Ding, ding, ding. We got a winner. So what does that mean? Instead of rewriting this whole thing as this crap, which is standard form, I can rewrite it as
X plus 1.
Beautiful.
And
Times
then
what?
X squared plus 3x plus 2.
Beautiful, bud. Very nice. Thank you so much.
Welcome.
All right, Nina.
Yeah.
Can you help me out with this part? How can I factor this farther? Or further? I never know which one is farther, further. Factor it more.
I got stuck there.
Do you remember so right here, you are focusing on this guy right here.
Right.
Did you ever watch the video that I told you guys to watch?
Yeah, I did.
Okay, what does this sign tell me?
It's you're gonna add.
But before it says that, it says something else. Yes, you are gonna add. There's something else it tells me.
Same signs?
Yes, so here's what that means. Nina, that means that down here in my bubbles, I know they're either gonna be plus, plus, or minus, minus. What does this one tell me?
They're both they're both plus plus.
Because this sign so this one tells me they're the same, but I don't know if it's positive, positive, or negative, negative. Since this is positive, this tells me they're both plus, plus.
Okay.
And like you said, you are adding, you're correct. So that means I need 2 numbers. Here's my game. I need 2 numbers that multiply to 2, but add to 3. What 2 numbers multiply to 2, but add to 3?
Yeah, 2 and 1.
Right? And then, what makes this bubble 0?
Wait, say that again.
What number would make this 0?
Negative, yeah, -1.
What would make this bubble 0?
-2.
What would make this bubble 0?
-1.
But I already have that, so I don't need that. But what does that tell me about this -1? Since there's 2 of them, it has a multiplicity of
2.
Right. So what does that mean for me? That means when I go to graph it, -1, -2. Now we're going to go up here and we're going to get our help. This tells me that there's a y-intercept at 2. So I go 1, 2. Since this is positive and odd, I know it's going to end up but start down. And I have a multiplicity of 2 here. So I'm going to go start down. Since this one has a multiplicity of 1, it's going to go through. It's going to come here. Since it has a multiplicity of 2, it's going to bounce and go back. And that's kind of a sketch of that graph. Is this starting to make sense?
Wait, so if it's odd, it goes through?
Yep. Odd multiplicities go through the x-axis. Evens bounce off and go back the way they were coming from.
Okay.
And remember, this isn't a perfect idea. This is just a sketch of this. This is an idea of what this graph would look like. Questions?
I have a question, but it's not on this. I'm just wondering when our next test is going to be.
Friday.
Friday. Okay, thank you.
Questions on this?
I have a question about the tests as well.
Okay.
Is that going on this grading period or next grading period?